It wasn't supposed to be there. Not in that region of space. Not with that mass. Not moving in that direction. And yet, every new observation confirms the same thing. Something the size of a planet, possibly larger, is drifting through interstellar space, and it's getting closer. This isn't speculation. The first anomaly was flagged by a deep sky survey designed to track distant objects at the edge of our solar system. At first, researchers assumed it was a data error, a miscalculation, background noise, but it kept appearing. Same coordinates, same trajectory, same impossible signature. So they looked closer. Using infrared telescopes, scientists began mapping its thermal output. That's when they realized this object wasn't reflecting light like a normal planet. It was emitting it. Faint, cold, but consistent. That alone shouldn't happen. Rogue planets, worlds ejected from their star systems, are not uncommon. In fact, astronomers estimate there could be billions drifting through the galaxy. But those planets are cold, dark, and nearly invisible. This one isn't. And that's where things start to break down. Because based on its luminosity and estimated size, this object should have cooled billions of years ago. There's no nearby star heating it, no radiation source strong enough to explain the readings. Yet it continues to glow. Not brightly, but enough to be detected across unimaginable distances. So scientists did what they always do. They ran the numbers, its speed, its vector, its gravitational influence. And what they found made even experienced astrophysicists pause. It's not just drifting, it's moving with direction. Now, in space, everything moves. But most objects follow predictable paths, dictated by gravity, momentum, and the structure of the galaxy itself. This doesn't. Its trajectory cuts across expected orbital patterns. It doesn't align with known stellar motion. It doesn't appear to be orbiting anything. It's just coming, slowly, but steadily. And it's heading toward a region that includes our outer solar system. But that's not the strange part. As tracking improved, scientists began to notice subtle fluctuations in its motion, tiny deviations, almost like corrections. At first, they blamed measurement error, but the pattern repeated, again and again, as if something, some force, was adjusting its path. That's when the conversation shifted, quietly, at first, then more. Seriously, because if this object isn't behaving like a natural celestial body, then what is it? One theory suggests it could be a failed star, a sub-brown dwarf that never ignited. These objects can emit faint heat and wander the galaxy alone. But that explanation doesn't fully fit. Because even failed stars follow physics. They don't change direction without cause. They don't maintain thermal output beyond expected decay rates. And they definitely don't move like this. This is where it gets uncomfortable. Because the more data comes in, the fewer explanations remain. Somebody do. Researchers have proposed that what we're seeing isn't a planet at all, but something else entirely. Something with a composition we don't yet understand. Others suggest gravitational interactions with unseen objects, dark matter concentrations perhaps, could be altering its path. But even that has limits, because the deviations are too precise, too controlled. And then it got worse. Spectral analysis revealed something embedded within the signal. Irregularities in the emitted radiation. Not random noise. Not cosmic interference. Patterns. Subtle. Repeating. Almost structured. Now, no one is claiming this is artificial. Not publicly. But the data doesn't behave like natural emission, and that leaves a question no one wants to answer. If this object shouldn't exist, and it shouldn't be moving like this, then why is it getting closer? By the time the second round of observations came in, the discussion had already shifted behind closed doors. Not because there was panic, but because there was no clear model that could explain what they were seeing. The object's thermal signature hadn't faded. It hadn't stabilized either. Instead, it fluctuated, slightly, but consistently, like a system regulating itself. That shouldn't happen. Planets don't self-regulate heat without an internal energy source, and even then, the decay curves are predictable, measurable, safe. This wasn't. And that's where things start to break down. Because when researchers extended the trajectory forward, projecting its path over the next few decades, they found something deeply unsettling. It's not just passing through. It's slowing down, not dramatically, not enough to notice in a single observation. But across multiple data sets, the pattern becomes clear. Something is reducing its velocity. In space, that requires energy, a lot of it. There's no visible force nearby, no massive object pulling on it, no stellar gravity well to explain the Oort deceleration. And yet, it continues, gradually, deliberately, as if it's approaching something. But that's not the strange part. The region it's moving toward isn't empty, but it's not significant either. No large stars, no dense clusters, nothing that would justify this kind of behavior. Except for one detail, our solar system sits along the outer boundary of that projected path. Not directly in line. Not yet. But close enough that, astronomically speaking, the margin is uncomfortable. This is where it gets uncomfortable. Because the closer it gets, the clearer the readings become. And with clarity comes contradiction. High-resolution scans have begun to suggest that the object's surface, if it even has one, isn't uniform. There are variations in density, regions that absorb radiation completely, sitting next to areas that reflect it in sharp, unnatural spikes. Almost like segmentation. Natural bodies don't form like that. Geological processes create gradients, smooth transitions, predictable layering. This doesn't follow any known pattern. And then it got worse. A recent analysis compared its emission spectrum over time and found a shift. Not random drift. Not environmental interference. A shift toward higher frequency output. In simple terms, it's getting hotter. But that's impossible. Without an external energy source, an object like this should only cool as it travels. Heat dissipates. Systems decay. They don't reverse, unless something is adding energy back in. Which brings us to the explanations no one agrees on. Some scientists still argue for natural causes. Unknown physics, exotic matter, interactions we simply don't understand yet. After all, the universe has surprised us before, but others are less certain, because every new layer of data removes another piece of that comfort. The precision of movement, the controlled deceleration, the structured emission patterns, the thermal increase. Individually, each anomaly might be explained away. Together, they form something else, something coherent. And that's a problem, because coherence implies structure, and structure implies intent. Now, that doesn't mean this object was created. It doesn't mean it's directed. It doesn't mean anything beyond what the data shows, but the data is becoming harder to ignore. And that's where things start to break down again. Because as models grow more complex, they begin to produce outcomes that researchers aren't comfortable publishing. Not because they're impossible, but because they raise questions that can't be tested. What happens if it continues to slow? What happens if its trajectory adjusts again? What happens if closer isn't just a coincidence of motion, but a destination? No one has those answers. Not yet. For now, all we know is this. An object that shouldn't exist is moving through space in a way we can't explain. It's getting warmer when it should be cooling. It's changing direction when it should be drifting, and it's slowing down when nothing is there to stop it. Which leaves one final possibility: that we're not observing something passing by. We're observing something arriving, and we still don't know why.